In this question, we have a single block of mass 20 kg which is placed over the tabletop like this. And we have to find the weight of the box and the normal force acting on it. In the second part of the question, another box of 10 kg is placed over the box of 20 kg. Then we have to determine the normal force that table exerts on 20 kg box and that 20 kg box exerts on 10 kg box. So let us firstly solve part A. The weight of block is given by W equals mg. Since in the part A only one block is placed on the table, so if this is the table and this is the block of mass 20 kg placed on the table, so then the weight of that block will act vertically downward, and due to Newton's third law, the table will apply a normal force in vertical upward direction. Since the block is at rest, so therefore there is no acceleration along the y-axis. So if we apply Newton's second law, the sum of all forces along y-axis will be equal to mass into acceleration along y-axis. If we insert values, you can see that Fn is toward plus y-axis and mg, it is vertically downward, so it is acting toward minus y-axis. So using this convention, Fn will be written as positive and mg is written as negative. It is mass. Since acceleration is 0 as the body is at rest, so we will insert ay equal to 0 here. This gives us Fn is equal to mg, and if we put the values, it comes out to be 19.6 Newton. So in the part B, we have now two blocks on the table. So block A of mass 20 kg is on the table and block B of mass 10 kg is on the block A. The weight of the block B will be acting vertically downward through its center of mass, and the normal force exerted on the block B by the lower block is written by the symbol small fn. Similarly, just as in part A, the weight of the bigger block will act vertically downward, which is given by capital Mg, and the normal force that the table exerts on the bigger block A will be now written by symbol capital Fn. Let us now draw the free body diagram of the block A only. So we can see in case of block A, there are three forces. One, this weight, which is of block A itself. Second, this weight. This weight is that of a block which is placed over the block A. So this will also act vertically downward. And there will be normal force Fn, which will act along vertically upward direction, and this force is applied by the table, so it is this force. So out of the three forces, two are vertically downward, so these will be taken with the negative sign, and one force is vertically upward, so it will be taken with the positive sign. So again, if we apply Newton's second law, sigma Fy is equal to capital M, which we are using right now in part B for the big box. So it will be capital M into Ay. And since again the block is at rest, so Ay will again be 0. So sigma Fy will be actually three forces. Fn, which is positive, minus Mg, and minus capital Mg. So on solving these three, we will get Fn is equal to small m plus capital M into G. If we insert the values, so small m, it is the mass of the smaller block, that is block B, it is 10 kg. Capital M is the mass of bigger block, it is 20 kg. And G is acceleration due to gravity, which is 9.8 meter per square second. And if we solve it, we will get the total force to be 294 Newton. Now let us now draw the free body diagram of only block B. If we go to main figure, we see that in case of block B, there is a force small Fn which is exerted by the block A on the block B, and it is in the vertically upward direction. And weight of the block B is acting vertically downward. No other force is acting on the block B. So the free body diagram of the block B will contain only two forces. Small Fn in the vertically upward direction, obviously with plus sign, and mg, which is the weight of smaller block, it will be in the vertically downward direction with sign minus. So again, if we apply Newton's second law, sigma Fy is equal to MAy. Ay here again will be 0, and Fy, sigma Fy will expand to small fn with positive sign and mg with negative sign. On simplifying, it gives Fn is equal to mg. Answer for the normal force on the block B will be 98 Newton.